A visitor older than our own sun just drifted through the solar system, and the James Webb Space Telescope caught something inside its glowing tail that scientists are still struggling to fully explain. This is the story of Threeey Atlas, only the third interstellar object ever confirmed passing through our cosmic neighborhood, and the strange chemical signature Webb detected that has forced researchers to rethink what kind of place this ancient traveler actually came from, and what its frozen chemistry might reveal about star systems humanity will never visit in person. The object was first spotted on July 1st, 2025, by the NASA-funded Atlas survey telescope stationed in Rio Hurtado, Chile, a network of instruments specifically designed to scan the sky for exactly this kind of fast-moving, unexpected visitor. Within days, astronomers around the world confirmed what the Discovery team suspected. This was not an ordinary asteroid or comet native to our solar system, but an object moving on a hyperbolic trajectory so extreme that it could only have originated from somewhere far beyond the sun's gravitational reach, drifting in from interstellar space itself. It became just the third such interstellar object ever confirmed, following the strange, cigar-shaped Oumuamua in 2017 and the comet Borisov in 2019. Once astronomers dug back through older survey images, they even managed to find faint traces of Threeey Atlas in data collected weeks before its official discovery. Images captured as early as mid-June 2025 that nobody had recognized as significant until the object's true nature became clear. The comet's orbital path alone told scientists most of what they needed to know about where it came from. Objects that belong to our solar system follow elliptical paths that loop back around the sun again and again, but Threeey Atlas is moving on a hyperbolic trajectory, meaning its path curves just once and then carries it permanently away, never to return. Its eccentricity, a measurement of how sharply an orbit deviates from a perfect circle, came out at more than 6, an extraordinarily high value that leaves no doubt the object is simply passing through rather than orbiting the sun in any lasting sense. Unlike every native comet and asteroid astronomers have ever tracked before. At its fastest, near its closest approach to the sun, the comet was clocked moving at more than 68 kilometers per second, fast enough to make clear that nothing in our solar system's gravity could ever hope to capture and hold on to it. What makes Threeey Atlas especially remarkable is not just where it came from, but how old it appears to be. Based on its trajectory and composition, researchers estimate the comet formed around a different star system entirely, and some scientists believe it may be older than our own sun and solar system, meaning the ice and dust locked inside its nucleus could have been drifting through the galaxy for billions of years before it ever crossed paths with us. Once astronomers realized how significant this object was, they scrambled to get as many telescopes as possible pointed at it before it disappeared from view forever, since interstellar objects like this one pass through only once and never return. Among the instruments trained on the comet was the James Webb Space Telescope, which observed Threeey Atlas for the first time on August 6, 2025, using its Near-Infrared Spectrograph. That instrument does not capture ordinary photographs the way people might picture a telescope image. Instead, it breaks down the light coming from an object into a detailed spectrum, allowing scientists to identify the exact chemical fingerprints hidden inside the glowing coma, the cloud of gas and dust that surrounds a comet's icy core as it warms up near the sun. What Webb found inside that glow immediately stood out as unusual. Astronomers noted that capturing the comet at all required unusually precise trajectory calculations, since Webb's spectrograph instrument has an extremely narrow field of view, and even a small error in predicting the comet's exact position could have caused the observation to miss its target entirely. The spectrograph revealed that the gas surrounding Threeey Atlas was dominated overwhelmingly by carbon dioxide, alongside smaller amounts of water vapor, water ice, carbon monoxide, and a pungent sulfur-based gas called carbonyl sulfide. On its own, finding carbon dioxide in a comet is not particularly surprising, since many comets in our own solar system contain some. What genuinely caught researchers off guard was the ratio between carbon dioxide and water inside the coma, which turned out to be among the highest ever recorded in any comet ever studied, whether native to our solar system or from somewhere else entirely. Scientists measured that ratio at roughly 7.5 parts carbon dioxide to every 1 part water, a proportion so far outside the normal range that it stood out clearly from the well-established patterns seen in other long-period and Jupiter family comets. That unusual chemistry offered scientists an important clue about the conditions under which Threeey Atlas originally formed. A coma, this rich in carbon dioxide compared to water, suggests the comet's icy interior may have been exposed to significantly higher levels of radiation over its long journey through interstellar space than typical comets in our own solar system ever experience. Researchers involved in the analysis suggested this could mean the comet's ices were altered by cosmic rays or other high-energy radiation over the vast stretches of time it spent drifting alone between star systems, slowly reshaping its chemical makeup long before it ever entered our neighborhood. Webb was not finished making discoveries once the comet swung around the Sun either. After Threeey Atlas reached its closest approach to the Sun on October 30th, 2025, at a distance just inside the orbit of Mars, the comet disappeared from view for several weeks as it passed too close to our star to observe safely. When it reemerged on the other side in December 2025, astronomers turned Webb toward it once more, and this time the telescope achieved something entirely new, the first ever direct detection of methane gas in any interstellar object. That methane had almost certainly been locked away in frozen form deep within the comet's nucleus since its formation, only sublimating into a detectable gas once the intense heat of the Sun finally penetrated far enough beneath the surface to release it. The second round of Webb observations also produced the first mid-infrared chemical fingerprint ever captured from an interstellar object, using a different instrument called MIRI that examines longer wavelengths of light than the spectrograph used during the initial August observation. Scientists found the timing of that methane detection especially interesting. Rather than appearing early in the comet's approach toward the Sun, the gas seemed to emerge only after Threeey Atlas had already made its closest pass and started heading back outward, suggesting the methane ice sat buried unusually deep within the comet's structure. Researchers believe that delay reflects just how long it took solar heat to work its way down through layer after layer of the comet's crust before finally reaching pockets of ice. The object first formed, possibly billions of years ago, around a star system that no longer exists in any form we would recognize today. Webb's observations were far from the only ones focused on this rare visitor. Nearly a dozen different NASA missions eventually turned their instruments toward Threeey Atlas as it crossed the solar system, including the Hubble Space Telescope, the Parker Solar Probe, the Europa Clipper spacecraft, the TESS planet hunting satellite, and the newly launched Sphere-X infrared observatory. Each contributed a different piece of the puzzle. Hubble captured some of the sharpest visual images of the comet's coma and helped researchers pin down the size of its icy nucleus, eventually settling on an estimated diameter of roughly 2.5 kilometers, making it considerably larger and more massive than Borisov, the previous interstellar comet studied back in 2019. The Parker Solar Probe, already flying remarkably close to the Sun as part of its main mission, managed to snap roughly 10 images per day of the comet during a multi-week observation window in October and November. Europa Clipper, on its own journey out toward Jupiter's icy moon, captured additional data from about 100 million miles away during a 7-hour observation window in November, while TESS spent a dedicated observing run in mid-January 2026 studying the comet's rotation and overall activity levels. More recent analysis added yet another layer to the mystery. In early 2026, a team of researchers studying the ratio of heavy hydrogen to ordinary hydrogen inside the comet's water, a measurement scientists call the deuterium to hydrogen ratio, found a value unlike anything previously measured in a comet from our own solar system. That ratio acts almost like a chemical birth certificate, offering clues about the temperature and radiation conditions present during a comet's formation. The unusual reading reinforced the idea that whatever planetary system Threeey Atlas originally formed within must have looked, in some fundamental ways, quite different from our own, hinting that not every young star system builds its comets in icy bodies using the same chemical recipe our solar system apparently followed. Not every scientist studying the object has stayed entirely quiet about more speculative possibilities either. Harvard astrophysicist Avi Loeb, known for previously raising the idea that the interstellar object Oumuamua might have been artificial in origin, published a series of papers and articles cataloging dozens of what he described as unusual or unexplained characteristics of Threeey Atlas, ranging from its retrograde orbit to the timing of its closest approaches to several planets. Loeb argued these details were worth investigating carefully rather than dismissing outright, and he suggested the object's path offered a rare theoretical opportunity for a spacecraft to intercept and study it directly. Most other astronomers working on the object, however, have pushed back against framing these details as evidence of anything artificial, arguing that unusual orbital geometry and rare chemical ratios are exactly the kind of things scientists should expect to find in a genuinely ancient object that formed under completely different conditions than anything in our own solar system. That tension between cautious speculation and mainstream scientific consensus became part of the broader public conversation around Threeey Atlas as it crossed the solar system, with headlines swinging between framing the object as a groundbreaking scientific opportunity and, at times, hinting at far more dramatic possibilities. For the scientists actually parsing Webb's spectra and Hubble's images day to day, though, the excitement was never really about aliens. It was about finally getting direct chemical and physical measurements of material that formed around a star system none of us will ever see up close. A genuine sample of interstellar chemistry that no laboratory on Earth could ever replicate, gathered from an object that will be gone from view within the year and never seen again by anyone on this planet. Even the sheer logistics of observing an object like this highlight how rare an opportunity Threeey Atlas represented. Interstellar objects move so quickly relative to the Sun that there is only ever a narrow window, typically just months, during which ground and space-based telescopes can track them before they become too faint or too close to the Sun's glare to observe safely. Coordinating observations across nearly a dozen different missions, each with its own scheduling constraints, instrument limitations, and competing scientific priorities, required an unusual level of cooperation across NASA's various mission teams, all racing against the same shrinking deadline as the comet sped toward and then away from the Sun. Mission scientists have compared the effort to assembling a puzzle under a strict deadline, where every additional week of clear observation time meant another chance to capture a measurement that might never be repeatable again for generations. As Threeey Atlas continues speeding away from the Sun, it swung past Jupiter in March 2026 at a distance of roughly 53 million kilometers, and it is now steadily fading from view as it heads back out into the depths of interstellar space, never to return again. Every telescope that managed to capture even a glimpse of it added something permanent to the scientific record, since once the comet slips beyond the reach of Earth's instruments, there will be no second chance to study it further. Researchers say the data already gathered will likely keep scientists busy analyzing new details for years to come, mining Webb's spectra, Hubble's images, and the readings from half a dozen other missions for insights about a visitor that may have been drifting through the galaxy since long before our own Sun ever ignited. NASA has already committed to preserving all of this data permanently in its public science archives, meaning researchers decades from now, using instruments and techniques that do not even exist yet, will still be able to revisit these exact same observations and search for details that today's scientists might have missed. In the end, Threeey Atlas leaves behind no mystery of alien engineering, only the quiet, humbling reminder that our solar system is just one small neighborhood in a galaxy full of ancient wanderers, each one carrying frozen fragments of a story that began long before any of us were here to witness it.